Good morning again, everyone. Welcome to another Science Tutor lesson. I'm Samuel Duncan, your math tutor for today, and we will be continuing our introduction to algebra. Now, you may wonder why it is that we spend so much time on factorizing. The thing is, factorizing is actually very fundamental to algebraic manipulation. And since we are not working with actual numerical values, it is very useful to write down algebraic expressions as simply as possible for further analysis. So we're proportioning quite a significant amount of time to understanding and getting adequate practice with factorization. Okay, so now we'll be looking at the highest common factor. The highest common factor of a set of numbers is the largest number that can divide all the numbers in the set without leaving a remainder. Let us take our three numbers here, 48, 54, and 63. Those numbers define the numbers in the set that we are dealing with right now. Now, if we look at all the factors of these numbers, I have them written down here, all the factors of each of these three numbers. Now, the factors written here do not necessarily divide into all three numbers, and therein lies the highest common factor, because it must be able to divide exactly into all three numbers. It must also be the largest number that can divide into all three numbers without leaving a remainder. So let's play a game of elimination. Which numbers are, first of all, common to all three? Now, we can quickly eliminate. We have an odd number here in 63, so we know that no even number will be a factor of 63. So we can immediately eliminate all the even numbers from our set of factors here. There we go. So now we are left, oh, we missed one, the elusive number 2. So we have eliminated all the even numbers from our set of factors. So we are left with these numbers 1, 3, 7, 9, 27, and 21. Now, are these numbers all factors of our set of numbers? Well, for one, we know that 7 cannot divide into 48, so it also becomes eliminated. 9 does not divide into 48 either. It's not a factor of 48. Neither is 21. Neither is 27. Neither of these numbers are factors of 48. So we're left with two numbers, 1 and 3. Now, 3 divides exactly into 48 to give 16. It also divides into 54 to give 18. And it divides into 63 to give 21. So 3 is a factor of all three, and so is the number 1. But 3 is the larger of the two numbers. Hence, the highest common factor of the set of numbers is equal to 3. Now, if we apply this to an algebraic expression, we get the same thing. Let us take an example of an algebraic expression. Let us find the highest common factor of the expressions a squared b and ab cubed. Now, our first step is to write down all the factors of each expression in the set of expressions. So, the factors are, let's start with this first term, a squared b. So the factors of a squared b, that is the factors, the expressions, the terms that can divide directly exactly into a squared b without leaving a remainder are a squared, b, and ab. Are we missing anything? I think not. Okay, now let us consider the factors of a b cubed. Factors would be a, we have a already, we have b already, ab is already listed, but now we can add a b squared. And a squared b is a factor of itself. Now let's consider the factors of ab cubed. The factors of ab cubed are a, we have already, b, have already, ab, already listed, but now we can add to this list a b squared and ab cubed as a factor of itself. Let us eliminate the common factors. We can eliminate a squared b immediately because a squared b is a factor of a squared b but not a factor of ab cubed. Also, we can eliminate ab cubed being a factor of itself but not a factor of a squared b. We can also eliminate ab squared because that's a factor of ab cubed but not a factor of a squared b. So now we're left with a squared, b, and ab. But we can also eliminate a squared because a squared is not a factor of ab cubed. So when all is said and done, we are left with three factors: a, b, and ab. Now, which of these factors is the highest common factor? And it follows from the definition. The highest common factor is the largest factor. So hence, the highest common factor in this case is simply AB. Now, there is a rule to remember when determining the highest common factors for algebraic expressions, and I will write that rule. To find the highest common factor, select the lowest power of each of the terms that is common to all the expressions.